Pre-calculus. Today our learning target is I can rationalize with complex numbers. So we're going to be looking at some division problems. And I can solve equations with complex solutions. So in your notes, we are dividing complex numbers today. And a couple general rules that you need to remember. First, never leave an imaginary number, in the denominator of a fraction or a division problem. So make sure that the I in the denominator, you can figure out a way to get rid of that. Secondly, you are going to rationalize the denominator by multiplying both top and bottom by I or the conjugate. And I'll explain what that conjugate is in a second. So when you hear me say rationalize, I'm basically asking you to get rid of the I in the denominator of the division problem. And there's different types of problems. And so we're gonna look at the easiest one first. So example 1. We have 10 divided by I. I stands for the square root of -1. We learned that earlier. Because of the fact that there's a square root in the denominator, that is not simplified in algebra. So because I stands for that, likewise it's not simplified. So your job is to rationalize. You're going to multiply the entire fraction, top and bottom, by the letter I to get rid of it. So anytime you have an I term in the denominator, you're going to basically multiply the top and the bottom by I. So it's going to look like this. When you are multiplying fractions, you know from the past that you can just multiply straight across. So in the numerator, you're going to end up getting 10I, and in the denominator, I times I, remember there's powers of 1 here, and when we multiply, the power or the product rule tells us to add powers. So that's going to end up giving us an I to the second back on the bottom. Okay, in the next step, you're going to drop your 10I down, and then you're going to divide through by I squared, and I squared is equal to -1. And then just make sure that you never leave, in a fraction or a division problem, you never leave a negative number on the bottom. So you're going to divide through 10 divided by -1. So the best answer is -10 and then I. This is a simplified answer to this problem. It is a division problem up front. Problem is we have an imaginary number on the bottom, and since imaginary stands for the square root of -1, that is not simplified in algebra. So you have to rationalize to find a way to get rid of the I. Anytime it's a term like this, the goal is to multiply both the top and bottom of the problem by the letter I. You have to treat the top the same as the bottom. When you do that and you multiply straight across, you end up getting 10I on top, I squared on the bottom, I squared changes to -1, and then, like I said before, make sure you never leave a negative number in the denominator of a fraction. You always simplify. Okay, let's take a look at number 2. Example 2, we have 9 plus 3I divided by 3I. And so, again, it's division. It has an imaginary number on the bottom. We're going to rationalize to get rid of it. We're going to multiply this entire problem, top and bottom, by something that's going to allow us to get rid of the I. In the last problem, I just multiplied by I, and it worked. The difference here is it has a coefficient of 3. you can either multiply the top and bottom by 3i, that will work, or if this is just one term, as it is, you can just multiply by I, the same as I did in example 1, and that also will work. The difference here is the numerator has two terms, so it's basically a binomial. So when you multiply I times the top, you're actually using distributive property. Yeah, just do the best we can. I know. Yeah, I'm getting ready for mine. I'm not worried about grading right now. Alrighty. Okay, talk to you later. Bye. Okay, so we're going to multiply the top by I, and to do that, you're going to end up getting a 9i plus 3i times I is 3i to the second power. And then in the denominator, 3i times I is 3i squared. Okay, so this is the first step. After we multiply the top by I, the bottom by I, this is what we're left with. Okay, in the next step, notice that we have an I squared showing up. So what we're going to do is drop our 9i down, 9i plus 3, and then change I squared over to -1. In the denominator, same deal. It's going to be 3 times -1. Okay, and then from there, we're going to have 9i minus 3, and we're going to divide by -3. Okay, so that's the next step. And one issue I see is that, again, I just don't like this negative in denominator. That's not simplified. So you're going to have to treat both terms separately. And what I mean by that is, like, take the 9i, kind of imagine dividing 9i by -3, and then the -3 by itself. So I'm going to write it separately. And it's going to be like -3 here, and then -3 on the bottom. Okay, and then we're going to have to simplify each like division problem separately, so we're going to end up getting a -3i. And then in this fraction, we have a -3 divided by -3, and that's going to turn out to be a +1. And so that last step that I've just written is really the best answer. This is the simplified version, not this one. And it's all because of that little negative. Some people like to think of it and skip this part writing it down, but do this part in your head, and you can do that. If you want to do that part in your head, 9i divided by -3, and jump from here to here, that's perfectly okay. And then do the other fraction as well, do -3 divided by -3, and call it +1. And then that's your solution. And the reason this is a good answer is because you don't see a I on the bottom of the division bar, you don't see a square root underneath, or a negative number. Those are things to look for. Okay, question 3. Number 3 is 5 minus 2i divided by 3 plus 4i. I see the I showing up in the denominator of my division problem, so it's time to rationalize, and we're going to put a little times sign here. And in the past two examples, what I've done is basically just notice that the denominator is a one single term, and so I was allowed to multiply the top and bottom by I, and that did work for me. In this problem, this is actually the incorrect method, so right now just make sure you're watching. So don't write this down. But I'm doing this because I've seen this mistake made commonly by students in the past. This problem is different than the first two because it has two terms in the denominator. It's a binomial. So multiplying by I is not going to help me, and here's why. When I distribute, I'm going to jump straight to the bottom. When I distribute I times 3, I'm going to end up getting a 3i. When I multiply 4i times I, I'm going to end up getting like a plus 4i squared. Now, I like the fact that there's an I squared on the bottom. That's good. It's going to change to like 4 times negative 1 in the next step. But the problem is I still have an I in the denominator. So I really didn't achieve my goal by doing this. And again, I keep repeating it, but the I cannot be present in the bottom of that division problem. And so this method, even though it worked for number 1 and 2, it will not work for a problem of this nature. So general rule of thumb is when you see two terms in the denominator and one of them is an imaginary number, thus this is complex, this method will not work. Okay, so here's how we're going to have to handle this. It's a different scenario. We are going to rationalize, but I want to refer you back to the notes previously when I gave you this word, the word conjugate. Conjugate means you are going to give me a binomial with the opposite sign. So for example, if, let's say in your problem you have 5 plus I, and I ask you to multiply that by the conjugate of 5 plus I would be the same number, 5, and I here, but instead of a positive, you would write the opposite sign. So basically, all you're doing in a conjugate is you're changing the middle sign. So let's do that here. In this problem, we would have to multiply the top by 5 by 3 minus 4i. So you're always looking at the denominator, you're picking out the conjugate, so I'm changing the middle sign, and you're going to divide the bottom by the same value. This, what I'm writing right here, this is the conjugate of the denominator, but also this as a separate fraction is just 1. Anything divided by itself is 1. So it's also a good time to think of it in this terms. The reason this works is it looks like I'm changing the problem, but I'm really not. This problem is just being multiplied by 1. It's just a really fancy way of writing 1. Okay, so we're still keeping the problem equal. Okay, in the numerator, you are now going to see a binomial here, two terms. So basically complex number times a complex number. This goes back to last class's notes. You're just going to do the FOIL method. First, outer, inner, and last. So let's see what happens in this case. Okay, we will start with 5 times 3, which is 15. Then we have 5 times negative 4i, which is negative 20i. Inside, you will get negative 2i times 3, negative 6i. And last, negative 2i times negative 4i is positive 8i squared. Denominator, we'll do one step at a time. Okay, yes, this needs to be simplified, but don't do it until the next step. Now your eyes should be drawn to the bottom. We have a complex number times another complex number. We have to do FOIL method again. Okay, on the bottom, 3 times 3 is 9. Outside is going to be a negative 12i. Inside is going to be a positive 12i, and last is going to be a negative 16i squared. Okay, in the numerator, we need to simplify. Okay, so we're going to end up getting a 15, we'll drop that down, 15. In the middle, these two terms are like terms and they need to be combined. Negative 20i minus 6i is negative 26i. The last term, I see a plus 8i squared, but instead of I squared, I'm changing it over to negative 1. Denominator right now, I see a negative 12i and a positive 12i. These are definitely going to cancel for me, and that's what I expected to happen. That's because I multiplied by the conjugate. So when you multiply by the opposite sign, the outside and the inside terms should always cancel, thus getting rid of your I, and that's the whole goal. Denominator now will read 9 minus 16, and then I squared changes over to negative 1. Okay, continue the process. You have to show every step, so yes, it takes some time. The numerator now, going back to it to simplify, we see 15 minus 26i and then plus negative 8. You can go ahead and subtract 15 and negative 8. So 15 minus 8 is 7, and then you're left with that 26i. Get rid of that. Then you're going to go to the denominator, and you see 9 minus 16 times negative 1. Well, that's the same thing as 9 plus 16. Negative 16 times negative 1. You can think of it that way. Okay, now you're going to simplify one final step, and you see on top you have 7 minus 26i, and in the denominator you have 9 plus 16, which is 25. And so this is where I am right now. The top is a complex number. No, I cannot subtract or simplify that. The bottom is just a real number, 25. I like the fact that 25 is not a negative number. There, I don't see an I here. I don't see a square root. And then really the last thing you need to check is to see if maybe this fraction here simplifies. And then also if you can simplify this fraction. And by that I mean reduce. So is there a number that will go into 7 and 25 at the same time? And the answer to that is no. Will I be able to simplify 26 over 25? And the answer to that is no. And so once you kind of go through that checklist and answer all those questions, then you know you have a really good simplified answer. 7 minus 26i divided by 25. Okay, so again, when your learning target one we got to today is on division, and you're never going to leave I in the denominator. You're always going to rationalize the denominator by multiplying by either I or by the conjugate. It depends on the problem. So you're only going to multiply by I if it's a single monomial term on the bottom. You're going to multiply by the conjugate, which is the opposite sign in the middle only, when you have a complex number or a binomial in the denominator. Please be careful, because a common mistake is people want to change this sign here as well. Always just change the middle sign for the conjugate, then go through and multiply top and bottom. Make sure you are showing every single step to get full credit, and that way you're also less likely to make a silly mistake. Okay, so we'll give it a try on division, and we'll pick up on solving the quadratic equations next class.